Alexa, trigger landing. Hi everyone, today I'll be showing you how I made this Arduino crane project to lift small payloads from downstairs to upstairs and vice versa. Let's get started. I started out with sketching some basic designs on how the whole system should work. I was experimenting with various bracket designs as well as pulley systems. I also made a component list of the parts that would be required for making this project as well as a rough idea of the circuit that I would be making. The basic interaction would be a voice command to Amazon Alexa, which will communicate to Blink Cloud via IFTTT, or I could open the app and give the command to the Uno with the Ethernet shield, so it would actually move the thing up and down. I made a bracket design in Fusion 360, which was basically a 90-degree bracket with a 45-degree rib to provide it with additional strength. I also took into account the thickness of the bracket, so it was very strong and could not be broken easily. Then I sent it to my 3D printer for 3D printing. So after printing the brackets, I drilled some holes in the bracket so I could mount it on a piece of wood. After the drilling process was complete, I did a test fit and everything worked fine as expected. I repeated the steps for the other bracket and now the mounting process was complete. I went ahead and also designed a pulley system in Fusion 360 which would be mounted on the motor shaft and could be screwed in with an M3 bolt so it stays in place. After the parts were 3D printed, I went ahead and did a test fit to make sure the parts were working together. And after a successful test fitting, I went ahead and did a power test to see if the motor would actually wind up. So I tied a piece of fishing line to the screw and powered the motor via a 12-volt power source. Everything was working great. Now it was time to mount the other hardware. Now it was time to mount the motor driver. I attached some spacers to the driver and marked the positions of the spacers. Then I drilled a 6 mm hole halfway through the wood. After which I drilled a 3 mm hole all the way through. Now I placed a screw on the 3 mm side and secured it with a nut. Now I secured the spacers just to realize that this was not going to work as the cables wouldn't fit. I later fixed the problem by stacking the spacers on top of each other and mounting it only on one side of the motor driver. Now it was time to fix the motor bracket. I drilled the holes for the bracket and secured it with M5 screws and nuts. Now it was time to do the wiring. For power distribution, I made a splitter cable which would distribute the power between the Arduino and the motor driver. Then I soldered the motor wires and connected them to the motor driver. I also connected the distance sensor and motor driver to the Arduino. At this stage, I fixed the sensor with some hot glue. I connected the Ethernet cable to a Wi-Fi extender pending to be installed. After the extender was connected, the LEDs were glowing, indicating success. Now, on to some coding. So this is the code that I came up with. This is the default Blink code with the authorization token. And next we have the variable declarations for the ultrasonic sensor, the pins and the duration and the distance. And then I made a function to check the distance. So whenever I call the function, it will check the distance and update these variables, as well as also print the distance. So this function, blink right v1, will be called when the value of virtual pin 1 is changed. We assign the value to this variable and then do the check distance. And if the pin value equals 1, which means go up, we have to do the following. So I used a do while loop because the loop has to run once to check the distance without making any further motor commands. If the distance is less than 50, turn off the motor. Greater than 50, turn on the motor. While the distance is less than or equal to 50, so the loop has to run when distance equal to 50, so we can turn off the motor right here so it doesn't keep running. And this will do the following. And state 0 means no movement, so we turn off the motor. Explanation is same as state 1 in this case, except it is downwards, so the conditions are flipped. And this will do the following. And again, the distance is less than equal to 290 centimeters, as the loop has to run so the motor can be stopped. Then we have the declaring pins as inputs and outputs code. Then we blink.begin and a blink.run. So that's basically it. Next, I created a basic Blink UI which could be useful when the voice command interaction isn't working. Then I went to ifttt.com/create and selected Google Assistant as my service. Selected say a simple phrase and just typed out the words that I wanted to say whenever I wanted the machine to be active. I typed trigger landing, send this down, etc, etc. I just went ahead and wrote the response that I wanted the assistant to say in return. Now for that, I selected the action service as webhooks. Then make a web request, and for the URL http://188.166.206.43/ the authorization token and update /v1 value equals 1 for going up or 2 for going down. Then the method was get and the content type text/plain with no content in the body. Now it was prompting to finish the applet, so after clicking finish, the connection was complete. Then I repeated the steps and created all the other required applets for Amazon Alexa as well as Google Assistant. And here, the project comes to an end. roller landing. Thanks for watching, and I'll see you in another video. For more details on the project, check out the Instructables guide down below.